and welcome to our Tuesday Cloud Coaching session. My name is Alexander Hödicke, and I will be your host for today's sessions. Today we're talking about running AI on Nvidia's A10 GPUs on Oracle Cloud, and will be presented by Yann, Nicolas, and Dora. So, talking about today's speakers, we have two special guests. Well, I mean, three special guests, of course, but two even more special guests. From Nvidia today, Nicolas, Global CSP Alliance Manager from EMEA, is going to present today together with Dora, both from Nvidia, of course, as a senior solution architect on deep learning for computer vision. And of course, our part is then presented on our side by Yann, who is an Oracle specialist on AI Infra and GPU content on OCI. And with that said, I'm going to hand it over to Nicolas, who's going to begin the session today.
Thanks a lot, Alexander. Nice to meet you all today. So I will start with a quick overview of what we do between Nvidia and OCI on the offer that is available for you to use before I leave the stage to my colleagues for the demo and the probably most interesting part of the presentation.
Nicolas, sorry for interrupting. Before you go ahead with the presentation, let's run quickly poll, because we have a question to ask our customers today. So let's save a couple of seconds to allow everyone to answer this question, and then we can move on with the presentation.
Can I answer too?
Of course. Interesting responses, I would say. Can you guys see the?
Yes, I do see. So many people are not using GPUs yet. Well, then we have a mix of people between graphics and AI. So I think you're in the right place to see what are the possibilities that can open for you.
All right, let's end the poll right now. Thank you guys for taking the time to answer. Nicolas, over to you.
Thank you. So let's start, and I will cover a bit of why GPUs are so important today in architecture of many projects of your companies. You probably have seen that AI is a bit of everywhere these days. It's not only talking about it, but it's really starting to change our daily life. Probably use ChatGPT, or if you haven't, your kids probably have to help them do their homework. But in a daily basis, you're probably using your credit card. Your bank is using AI to do fraud. You are working in a supermarket. The camera are using AI to detect theft or to detect missing items in the lines. You might have done a medical exam on AI. Have been helping your doctor to diagnostic you, or maybe to determine the very specific treatment for you. So I'm starting a GPU presentation. I'm not even talking about graphics, because today GPUs are as much important for everything around compute, artificial intelligence, as they are about graphics. Why is that? Why are they so important for artificial intelligence? The reason is that anything around artificial intelligence requires massive compute capabilities. If you take traditional CPU architecture, you'll have starting from 2 cores for the smallest one, but up to 64 and 128 cores. They're powerful cores, they can do powerful compute, but they're sequential. AI, like graphics before them, requires massive compute capabilities in parallel. If you do graphics, you want all your pixels to show up at the same time. So that's why GPUs were built for parallel computing, to show all your pixels at the same time. It's exactly the same thing with AI. You want to go through millions and billions of possibilities for each request as fast as possible. That's why modern GPUs have hundreds, up to several thousands core to handle massively parallel workload. That's why we've seen over the past few years this massive improvement in performance. GPUs have been outpacing Moore's law by an order of magnitude. Over the past 6 years, our GPUs have progressed about 6 times with a mix of hardware and software progress, where CPUs or Moore's law was about an 8-time factor. So this is what made these changes that you see today possible. This is what opens so many possibilities for new use cases for you, either new services for customers or basically improving massively existing processes, getting them faster, more accurate than what was possible before. You can think in 2 ways. You can think GPUs will help me be faster, more efficient, and get better results. The other way you can do it is that for the same amount of energy, you'll get far better performance. If your concern is powering your data center, is improving your carbon impact, GPUs are also great at helping that. For an equivalent amount of power compared to CPU architecture, you get 26 times the performance in terms of power. So GPUs are a great way not only to do graphics, which is the obvious one, but also to bring massive innovation to all your software and services. NVIDIA is at the heart of that. We are at the heart of that with our hardware, or GPUs, or networking, and Oracle Cloud has been a great partner of us for that. But as important, NVIDIA is at the heart of that because of our developer libraries, or pre-trained models, or purpose-built frameworks that address the most common challenges of AI, computer vision, language, text-to-speech, etc., etc. We have a few dozens of them that help you get to results faster. So NVIDIA is more than hardware. It's about helping you as developers to get to results faster, avoid reinventing the wheel, get the best performance out of your machines. What you don't see here is overall infrastructure, and that's really where we're partnering with Oracle Cloud. Oracle has been a great partner adopting all of our technologies, or GPUs, or networking, and bringing full software support of the NVIDIA AI platform. Everything works today on OCI with the best performance you can get on the market. Let's deep dive a bit today in a few use cases. So we'll focus today's session on one of our GPUs, the Nvidia A10. It's one of the many GPUs that are available in Oracle Cloud. You can see they have A10, H100, A100. So A100 and H100, which are more dedicated to compute, are often mentioned because they are the biggest and fastest, but that's not always what you need. A10 is a great GPU, very versatile, that can serve a large number of workload. It can serve graphics, it can serve compute, and it's very well designed for inference. So running AI in production, not the heavy lifting training part, but really what is in the end the goal of any training for AI. It's running in production my software to serve my goals. So NVIDIA A10 was released last year with a lot of improvement from previous generation. Before it, T4 was often the one recommended for inference. It starts to show its age. A10 is based on the Ampere architecture and has brought many improvements, both in graphics and in compute. In graphics, it has brought our second generation NVIDIA Ray Tracing Core, or RT cores, which helps you deliver far more realistic results for graphics, and it can be gaming, it can be for manufacturing design, it can be for media creation. That brought massive improvement over previous generation, with 2 times the performance for ray tracing, also some improvement in more general rendering compared to previous generation. But to focus on today's workloads, it also brought massive improvement for inference with 3rd gen Nvidia Tensor cores, bringing 2.5 faster inferencing time compared to the T4s that was the most common choice before, bringing improvement for inference, bringing new features like sparsity for inferencing, on the full compatibility with latest Nvidia AI platform. This shows in the results. You get better performance for graphics, you get better performance for inference, for language, for generative AI, and all the new workloads that we see emerging more and more this last few months. But it also brings better performance per dollar, whatever way you choose to run it. OCI is a great platform to have it to have it in production. It's readily available. It's readily available in hardware, bringing the instances, but it also supports our full AI platform. So everything that Dora and Yann will show you, all the software will run on the Oracle Cloud infrastructure, will run on A10, bringing the full stack of NVIDIA training for inferencing. All our models are supported, making it easy for you to develop. The easiest way to get started is really to jump into the Oracle Cloud Marketplace, deploy the NVIDIA GPU Cloud Image machine, and it will come pre-configured with everything you need, drivers and containers to run all our pre-trained model. Get started with that, deploy on A10. It's a great machine for development, for inference, and to show you a few examples of that, I let the stage to Yann and Dora. Thanks, everyone.
Hello, everyone. I think it's my turn now. And my goal today will be to show you how you can create and deploy an A10 virtual machine, A10 GPU-based virtual machine on OCI. And first thing first, we will start by creating a virtual cloud network, which will be the basic networking infrastructure to deploy our instance and some options. So I will just use the VCN wizard. The easy way, my VCN name will be, let's say, coaching VCN. It will run in my compartment. And I will basically only use the default options, and we'll add later configuration features if we need them. So we create the VCN. Only takes a few seconds. And once it's done, we will have the perfect infrastructure to deploy our instance. So VCN is created. It's got a public subnet and a private subnet. Now we switch from networking to compute and select instances and create instance. Let's call it again coaching A10. Same compartment. I'm located in our Paris region, one availability domain. And what I will use first, what I will change here is the image. I'll take the one Nicolas just talked about, the NVIDIA GPU Cloud Machine image, latest build from April. And you see that automatically OCI selected the virtual machine, so the shape that fits most this particular image. Regarding the networking, it it's already okay. That's the one we just created. And in order to be able to connect to this instance, I will add my SSH key. And I will also add the one from Dora, so she can connect to this instance. By default, the boot volume is 50. I will add it 50 more, 100, and we should be okay. Let's create the instance. The instance provisioning takes approximately 30 seconds for a virtual machine. So in the meantime, what we can do is go to the storage section, and here we can create a bucket that we name coaching. And this bucket, I don't know yet if we're going to use it or not, but that's the perfect place to store your models, your data sets, and everything you need to have quickly available on the cloud without to have to download and upload locally. So let's go back to instances. And my coaching A10 is ready to be used. I can now simply SSH to it. Oh, I was a bit too fast, a bit in a hurry. Just need a few additional seconds to finish the configuration. Yes, I mean, no, I didn't use the right user. Sorry, let's do it again. OPCs for our Oracle Linux based instances. Here, the Nvidia GPU cloud machine is based on Ubuntu, so the username is Ubuntu. Okay, here I am. And as you can see, if I enter the Nvidia SMI commands, I have my running A10. It's available here. This is the Nvidia CUDA driver versions, and means that the GPU is available, for example, to run your TensorFlow model training or your PyTorch model training. We also have the Nvidia Docker utility ready. So we could just start working from here, but there are additional features I'd like to add on this instance, and one is a graphical environment. So the one I'm gonna use here an utility called task SEL. And with task SEL, it's very easy to select graphical environments and install all the package and dependencies. And I will simply use the minimal one. I don't need too much. And it will download all the different features. Again, instance creation, it's very fast. You need a virtual cloud network. You need to select an image. You need to select the shape. The provisioning is very fast. You may require to add some policies depending on what you want to do with your instance. But here it comes as a server image, doesn't have a graphical user interface. So it's best, for example, if you want to run a Python notebook on this instance because of some networking challenges, It's one of the options that are available. And next, when the configuration is finished, we will simply reboot this instance, install a VNC server, and connect with the VNC to this machine. And once it will be fully configured, Dora will be able to work with it. So everything we are doing is live. So the time it takes now is the time is going to take exactly for you, providing you have the same networking performance. Okay, should be finished in a second. It's the same for Oracle Linux images. You can use them as server images, but you can also add a package installation just to have access to this server. Let's quickly reboot this instance. Just a time for the graphical user interface to take effect. And the VNC server we are going to use is Tiger VNC. You're probably familiar with it. And we will use a VNC client on this laptop. So let's see if it's ready. Again, maybe not. Yes, it is. Okay, perfect. VNC server sudo apt install. I don't remember the name of the package exactly. So Tiger VNC. Okay. So those are the two, the standalone server. And I think I also need this one. Yes. Okay, and VNC server to launch the server. Password. Again, password. Nope. Okay. And one more thing I need to do. Oh yeah, I forgot. I forgot to. Where is it? I forgot to open a port in my virtual cloud network, because by default everything is closed. So if I want to open a VNC session, I need to add an ingress rule in my security lists. And the port number is 5901. Okay, and what I also need to do here is to create an SSH tunnel. And for this, I need this IP address again. So SSH tunnel is basically redirecting the port of the virtual machine on my MacBook. So it's SSH -L, the ports, my machine, second port. I'm redirecting on the same port, And now it's address and a few options. Okay. VNC server. Okay. And now, if everything is fine, I can connect. Here you go. Ask me later. And again, here we have the same utilities as we've seen from the shell. So if you prefer to work with a graphical user interface, just use this method. Can I resize it? A bit slow. My connection is very slow, but yeah, Nvidia SMI. And that's it. The instance is ready to work with, to run your AI applications. And on these comments, I will simply hand over the presentation to Dora. Thank you.
Hi, everybody. Hope you can hear and see me well. Thank you for inviting me to this webinar, and let's start with sharing my screen. Like this. Should be okay. All right. So after you see how you just saw how to configure your Oracle VM instance, and in fact, I am connected on exactly this kind of instance. And as you can see, it's the same A10 with 24 gigabytes memory, and I will do my demo on this instance. So thanks, Yann, for configuring it. And the demo will be using our Triton inference server, because on this A10 card, as Nicolas introduced you, you can do a lot of inferencing of your AI models, or not AI, even if you are not specifically using GPUs, you can use Triton inference servers, but here, of course, we will do the demo on an A10 card using this inference server called Nvidia Triton. So the demo will be, well, I will just walk through this tutorial, which consists in a computer vision application that you may have heard of. It's a stable diffusion model. So it's the image generation. It's an image generation model where you can just type a text and it will generate the corresponding image. And so the goal is to see how easy it is to deploy such a model from an AI. So yeah, it's an AI model, and to by using Triton, it will make us even easier. So to start, let me introduce you a little bit Triton with a few slides, just to contextualize a little bit. So when you are starting AI, but so on GPU or not, as you can see at the bottom, this challenges of inferencing also applies for CPU. Because so first of all, you may have to define your application. Is it real time? Is it not? Is it in streaming mode, etc.? So you may have some constraints, and then you may have different frameworks. Your developers would love working with Python simply, or just XGBoost for ML models, but maybe also with TensorFlow, PyTorch, or even so. Everybody would come with a model of the different frameworks. with model of different architectures, maybe some decision trees, but maybe some convolutional networks or transformers for the latest ones, etc. So you may encounter different environments. And then for your deployment, of course, here we are talking about Oracle, where you can deploy, but also using the super services like Kubernetes. You may want to deploy on different services and also on different locations. So either on the cloud, but maybe also on data center. So Triton inference server would help you in all these situations. And so, of course, here we are talking about cloud and Oracle deployment. And so the Triton inference server itself is just as simple as this. So it's this green box communicating with the outside with a client library. So Python or C++, you may send your queries and wait for results as a client. And the Triton server itself would interrogate actually a model store where you would have put your models already, your AI models. And then inside, it's just an orchestrator. So it managed all the queries together through HGPC or gRPC standards. And then with so managing all the different backends that we mentioned, it will do the inference step for you. And then it had some exciting capabilities as dynamic batching or concurrent executions. And you can follow the metrics of your GPU or CPU usage by monitoring it on tools like Kubernetes and Prometheus. And yes, as I mentioned at the beginning, it works indistinctly with GPU or CPU as a hardware behind. So you just have to mention which one you want to use. And that's mainly it for Triton's inference servers. So concurrent model execution, just the capabilities to have different models in your model store and then send lots of concurrent requests and process them in parallel so that you don't have to wait for one before sending the other results. It has this multiple instance capabilities of running concurrent models at the same time. And also the dynamic batching, which is just about batching the requests before sending them together, because we have some optimized tools that are better at running stuffs in batch, where and it would increase a lot your throughput while a little bit of latency increase, but then it's different architecture, maybe it's not a problem. So that's mainly what I wanted to introduce you about Triton. And now let's go back to the tutorial and a little bit go through. So I will just give you an overview of the stable diffusion architecture. So it's a bit of a special one, and it's a good example here because we will be able to show how you can manage complex pipelines with different types of models. So stable diffusion, as I said, you will have a text input prompt. So you will enter your text as an input, and then it will be processed by some different large language models. So here it's CLIP, for example, tokenizer. The first step is to transform your text into figures. And this will be done with Python tokenizer, very simply. And then after that, you enter the text encoder, which is really the large language model processing the text input. And this will be an ONNX model, just for the example. And after that, we will go through the diffusion process itself. So here it's done by a UNet. UNet is a neural network architecture. And this UNet will be downloaded from Hugging Face as a PyTorch model and run through a Python code that will iterate over this as the diffusion process intent. And then after we have the latent, so it's specific to the stable diffusion architecture, then we need a variational autoencoder, and here used as a decoder to get a nice pixel-based image. And this will be done with a VAE model, which will be already converted into TensorRT, our accelerating library for GPUs. So this will be our pipeline today. So it's quite a complex one, I recognize, but it's also the occasion to show you and demonstrate how we can use different backends inside Triton Inference Server, and all this will be done on our A10 graphic card. So with that said, yes, you could read the details on this page. I will share it with you at the end of the session. But then, so what we will need? So Triton Inference Server, as I mentioned, is a container. So you can just download the container from our NVIDIA platform, so NVIDIA NGC Cloud. And this is already very nicely configured in your Oracle instance that Yann just demonstrated before. So I simply have to go on, so I am on my instance. I also git cloned, of course, the code here, so you can see in the ls there that I have the simple code that is here already. So on this place, I just have to run the Triton Inference Server Docker. So let me do it right now. Yes. So Docker run, and here in my workspace, I have the code, the GitHub code. So here we are. After that, I will show you. So I did it already because it takes a little bit of time, but we will go through the codes here. So I also need to install some requirements. I will do that while explaining things. So just, yes, installing PyTorch, installing Transformers library. This is just for Triton to be able to infer this specific model. And as I will have to download things from Hugging Face, I also need to enter my Hugging Face login. So let him do the pip installs and then explaining the rest. So exporting and converting the models. So this can be done through another Docker with PyTorch already installed on it from our NVIDIA repositories as well. And this will just consist in transforming the Python or PyTorch models into ONNX. So if we have a look into the export.py file, it's just running some torch to NNX export functions of the VIA model and of the text encoder model. So this will convert the models into ONNX format, as we saw on the general plan here. We will have the text encoder into ONNX, and the VIE have to go through, ONNX before being converted into TensorRT. So this will be done with another command. So now that we had exported our model into ONNX, we will also convert the VAE model into TensorRT, which simply this line of code here, very easy. So TRT exec, and from ONNX, you will get a VAE.plan model, which will be a TensorRT optimized model of this VAE. So you need to put some input details so that it's really optimized for the shape of the images you will have to manage in your pipeline, but this is the detail. And also here, nice FP16 information that will convert our model from FP32 into FP16 without losing any accuracy. So this is a quantization form, actually, that it's automatically done by TensorRT if we precise it. So we will gain a lot of compute speed and memory here by doing that. And so the models are already in the model repository, as I did it before, so we can check. In the meantime, it just finished the pip install, and so we have just to put my Hugging Face login here. Okay. Yes. Successful. Right. So yes, I wanted to show you very quickly the model repository. So where I put the different models. So the text encoder and the VAE are already there. And in the text encoder, we have an ONNX model, yes. And in the VAE, we have model plan from TensorRT. Yes, so we have our model ready, and as you can see, we also have a pipeline here, which is actually the full pipeline brought together in Python code. So this is also available here. I can just show you quickly. Model repository pipeline, it's here, and it will do the initialization of the other models that will be used in Python, so directly from the diffuser and the transformer libraries. So those are initialized at the very beginning when we will launch the server. And after that, at the execution step, it will reproduce all the steps of the diagram that I showed before. So by getting the input from the request, by tokenizing the text, by querying the text encoder. So here we will call a model by an inference request. And after that, by running the scheduler and loop over the diffusion model. And after that, running the VIE, so the autoencoder, and at the end, getting back the image. So this is what is happening. And this code here in Python is called business logic scripting in Python vocabulary, where you can write whatever you want to do, requesting different model in a full pipeline. So this is really interesting. And this is actually seen as one model in the Triton inference server. So let me continue with the server. So we will launch it and just simply call Triton server and giving him the path to the model. And we have an error here, of course, because my model repository is not called models, but model repository. Okay. So this is what I did here. Let's go back to the explanations. So we exported our model and we just launched the server. So what's happening here, it's downloading the models that are not already in the computer. So the ones that we will download from Hugging Face. This is done only once as initialization. And so here it's downloading the unit, actually, the diffuser one. So it won't be very long. And while doing that, we will also run our client so that we'll be able to send requests. So let's go here and run the client. So the client is another Docker, simply the same, but with SDK at the end. And this can be installed on a different computer, not necessarily on the same as you will. It's your client actually. You also need a Gradio interface just to pip install. And on this client, we will, as soon as the server, let's go back. Yes, it is ready. So the server is ready. So the full pipeline here is ready to infer at this port. gRPC or HTTP are the standards that we mentioned at the beginning. So going back to the client side, now that our server is ready, we will launch the client. And so I prefer the GUI interface so that we have a nice interface, and we will start playing with stable diffusion as soon as this would give me, yes, a public link. Actually here it's just hop, and let's see what is this interface. Yes, simple prompt, and it will answer here. It will generate here the image. So let's try, I don't know what I have here as a, okay, well, this is very simple, a cute, magical flying dog, fantasy art, drawing Disney concepts, whatever. You can describe whatever you want here. And then I just click on generate, and we wait a little bit. We can have a look to what's happening on this here. It finished already, so we did 15 iterations about the unit model. And we have our flying dog. Excellent. Let's try with another one and just have a look to at the Nvidia SMI part, so that we can see that our GPU is actually doing something. I will change that to another one. Let's see what's happening here, and just resize a little bit that so that we can see here in the watch. So here we are doing nothing, so we have 0%, and generating an image, wow, it's beginning to be hot, and 100% usage. And yes, as soon as it finished, it goes back to 0. Yes, so this is how we can use an A10 graphic card to do inference on a stable diffusion application. And you could go further by analyzing a little bit of the so you could do also model ensembling. So today we used looping execution as business logic scripting in a Python script, but we could also use model ensembling. Very interesting. I will let you have a look to our documentation about that, but also allowing you to do complex pipelines just linearly, and it's seen as one model, whereas inside you have several different models. So it's quite the same as the business logic scripting, but business logic scripting allows you to do some more complex stuff with your own Python code. And yes, so analyzing the performance, so Nvidia SMI is nice. You can see what's happening on GPU, but then you could go further by using Personalizer, which would give you some nice curves about throughput and latency compromises that you would need to tune. And so this is one part of the analyzing capabilities, but you have also the model analyzer, which will really give you even better curves and help you to define your configuration. We did not really talk about the configuration, but let's have a look about that. Configuration files are next to each of the models. So for example, here, it's simply a text file with the name of the model, the platform, so that Triton knows how to use it. And here it's a ONNX model. And then you have the inputs and the outputs, so that you can just communicate in your requests by saying, this is my input and I want the output to have this name. And also you can specify the instance group, so it can be GPU, but you could also write here CPU, and then it won't use the GPU, but CPU instead. And you could put here some multiple instances, so by adding a flag here, count, instance count. And if I put more instances of my model, I would be able to run concurrent executions, as I mentioned at the beginning. So this is how you could configure it. So yeah, a lot of documentation on Triton that I invite you to have a look at. And those tutorials are quite simple to go through as well. And I think with that, I quite finished. So if you want to play more, feel free to send me your prompt, and we can generate images, or we can also answer some questions. Yes. Let me know what you prefer.
Perfect. Thank you very much. What a great document presentation. The flying dog, the dragon dog, was absolutely worth setting up this environment with A10 on OCI. We saw first the introduction of A10 OCI GPU loads. Then we had Yann a presentation on how to configure from an infrastructure point of view, and then we saw how we can leverage this GPU power for these image generation processes, for example. I will go towards a quick Q&A part now and start closing the session in a minute. But before we do that, I'm going to launch the final questions for today's call. I will leave it on while we talk throughout the last questions and slides. Feel free to answer these questions as well now, going forward. Right, we had a couple of questions. And Dora, can I ask you first? There was one question under the answered questions panel, the last one, where somebody asked about the link for the GitHub repository. Can you put the link for the GitHub repository in the chat and maybe also in that question? That would be great. Then we had another question. I'm not sure if this was already answered live or not, but somebody asked on the selected VM GPU A10 shape. It has 240 gigabyte memories listed, while A10 has 24 gigabyte GDD6. Is that some desired main and GPU memory ratio? Is that something Yann maybe, or anybody from the panelists can address this question? If not,
sorry, Alexander, can you repeat the question?
Yes, under the answered one, there is the second question from the top. It's around the shape VM GPU A10-1. It has listed 240 gigabytes of memory, while A10 has 24 gigabytes of GDD6. And I think
must be a typo.
Yes, no, the question is mostly on the ratio between RAM and VRAM. So roughly you have a 1 to 10 here. There's no simple answer on that. I mean, the ratio between the RAM and VRAM always depends on obviously what you do with the machine. It's a relatively common ratio here. It might be easier on classic RAM than needed for some use cases, but overall that's nothing extraordinary. That leaves also some room for applications that might not need only video RAM or GPU RAM and use more classic RAM workload. I don't know, Yann or Dora, if you have some additional comment on that, but.
Yeah, one comment. This virtual machine is built out of our A10 GPU bare metal server, and this bare metal server has 4 A10 GPUs and 1 terabyte of RAM. You can also access, of course, this bare metal server on OCI, and it is the same for the VM.GPU.A10.2. which will have 2 A10 GPUs and 480 gigabit of RAM. So it's just a split of our bare metal server, which has 1 terabyte of memory.
Okay, thank you very much. If you have any other additional questions, everyone, please join us on our Slack channel, which I just shared again in the chat. Okay, with that said, let me just share the final closing slides. Ending the poll. Thanks very much for your poll input. With that said, thanks again for your attending. Thanks again for all your presenters. This is our DevRel Slack community and our email address. Thanks everybody for attending and have a great day. Goodbye.